So 9-7 is scale and volume. We're looking at if you change the scale of something, so if you make it twice as big, you make it 3 times as big, what if you only make it bigger in one direction instead of like in 2 or 3 dimensions? What happens to the volume of the object? And that's kind of the point of today's notes. And the biggest part of today's notes is that there's really just kind of a chart. And I want to look at dimensions changed, so number of dimensions changed. So that's my first column. Then the second column is going to be the effect on prism volume. And if you think back to prisms, prisms were the 3-dimensional objects that had 2 identical sides that were parallel to each other. So like a cylinder, you could look at something like that, or really kind of like any sort of like a box shape. But you have to have like the base, 2 bases that are identical, that are opposite each other, that are congruent. And then the other sides could be 4 sides, could be 6 sides. Focus, please. Good. All right, so if you're only changing one dimension, so if you're making something, say, twice as wide, so you're keeping the same height, keeping the same depth, making it twice as wide, what's going to happen is the volume is going to be multiplied by, I'm just going to put in an S, where S equals, maybe I'll squeeze it in over here, S equals the scale factor. Yep. So if you're only changing like one of the dimensions, so you're making it like twice as wide or twice as tall, but you're not changing the other dimensions of it. So you just take and multiply by the scale factor. So if you're making something twice as big, twice as wide, but same height and same depth, you'd have twice the volume. You'd multiply the original volume by 2. If you're making something 5 times as tall, but keeping the same width and the same depth, then you do the volume times 5. That'd be the scale factor. Yes? Okay. If you're changing 2 dimensions, that's going to be the volume times the scale factor squared. So in other words, if you're making something twice as tall, that doubles the volume. But if you're also making it twice as wide, that's going to double the volume again. So it has to be a 2 squared or a 2 times 2, a 4 times as big. If you're changing all 3 dimensions, then it's going to be the volume times the scale factor. Anyone? Cubed. Yep. Because if you're making something, say, 4 times as tall, that'd make 4 times the volume, but 4 times the width, another times 4. 4 times the depth, another times 4. So you'd get it being 64 times the original volume. If this one here is kind of more, so I'm going to do an example 1. And my example 1 is somewhat just kind of how could you figure it out if you totally blank on it. But let's say you have, I'm just going to take and draw like a little square. This will work at least for those first 2, the 2 dimensions. But if I have this thing here, I'm going to say it has a certain amount of volume to it, even though I'm really just drawing it in 2D. If I were to take and double that in 1 dimension, do you agree now it has twice the volume? Is that green?
Yeah.
So in 1 dimension, then, you just multiply it by, whatever you changed it by. Where if instead you're doing 2 dimensions, so say I'm doubling it in 2 dimensions, now I have 4 times that original volume. So it'd have to be the original volume, maybe do that in green. So my original volume then times, I'm doubling it, but in 2 dimensions. So it's 4 times the original volume. Good? If we jump ahead to this here, and I don't know if I'd try drawing this. I slurped a picture from the book just because I figured my drawing would kind of stink. But I'm going to say example 2. You probably could get a decent amount of this down without even having the drawing. Is if you get a question that says, what's the scale factor? So find the scale factor. So the scale factor, I'm going to put it in red because this is worth knowing. So scale factor. To figure that out, it's always going to be the new length divided by the original length. And a lot of times you can just look at it and tell. Like for my example here, if I were to take my red one's my original, my blue one's my second one, if you're looking at that length, maybe we could call it, the scale factor is 2, yes? The blue is twice as big as the red. So the scale factor is 2. If you wanted to, you could actually go through and calculate, okay, the new length, that blue, is 6 centimeters, divided by the original length, the red, of 3 centimeters. So you end up with 2 for a scale factor. That'd be the scale factor for that length. You could take and do the exact same thing with any of the other dimensions. So if you were to pick these two here, you'd find that it's also twice as deep, or maybe the width then is going to be a 2. So it'd be 8 divided by 4. You could do the same exact thing with the height. You have a new height of 4, the original height of 2. So this one we have a scale factor in all 3 dimensions. Good? So if you had that, even if you didn't know all the dimensions of the old ones, you could say, well, what's the dimensions of my thing in red? So the volume in red, it's 2 centimeters times 3 centimeters times 4 centimeters. So I get a 24 cubic centimeters. Yes? So that's my one in red, or maybe you could say the first volume. Well, if you wanted to figure out what that's going to be for the blue one without going through and actually doing the math, if the blue one's twice as big in all 3 dimensions, we'd have to multiply by 2 to the third. So the blue one then would just be that times 2 to the third, or 24 times 8, which ends up being 192 cubic centimeters. So we found the scale factor, but then we also kind of went on and did the last thing. Maybe one final comment, and then I'm done. Assume when the book just says, here's an object and the scale factor is 5, assume that they mean they made it 5 times bigger in all 3 dimensions. Unless they tell you it's only a scale factor or scale change in 1 dimension, assume it's all 3. That's pretty safe. The other comment I probably should make is all my examples are where you're making something larger, but it'd be possible to have something with a scale factor. So maybe I'll say S, my scale change is 1/3. So then what that means is you're taking it in each of those dimensions, you're making only 1/3 of what it was originally. And, is that fair? All right, that's it for this section.